Welcome to another deep dive. Today, we're going to delve into the fascinating world of William Gilbert. He's often called the magnet guy, but trust me, there's a lot more to him than just that. We've got a ton of great sources here, so get ready for some aha moments as we uncover the secrets of this scientific rebel.
Sounds exciting. I'm ready to dive in.
All right, let's start with a fun fact. Did you know there used to be a unit of measurement named after Gilbert? The Gilbert. It was used to measure magnetomotive force.
Ah, yes, the Gilbert. It's actually been superseded by the ampere turn, though. It's a great example of how scientific understanding is constantly evolving.
Right. Even though the unit is gone, his name is still out there, which says a lot about his impact. But let's rewind a bit. Who was William Gilbert? Well, he was born in England way back in 1544. He studied at Cambridge and eventually became a physician. He even served as Queen Elizabeth I's personal doctor.
Wow, that's quite a prestigious position.
It was. But Gilbert's real passion was understanding the natural world, especially magnetism. He wrote this amazing book called The Magnete, where he used a model Earth, a terrella, to study its magnetic properties. Before Gilbert, people had some pretty wild theories about why compasses point north.
Oh, yeah, like what?
Some thought it was the pole star pulling on the needle. Others believed in a mythical magnetic island somewhere out there.
It's funny how those early theories often mixed real observations with mythology and folklore.
It is. But Gilbert wasn't buying any of it. He used the terrella to demonstrate that the Earth itself is a giant magnet. That's why compasses align north-south. It was a revolutionary idea.
Absolutely. It completely changed how people understood our planet.
Now think about figuring that out back in the 16th century. I mean, how did he even come up with these ideas?
Well, he was a meticulous observer and experimenter. He didn't just rely on speculation or ancient texts.
And that's what sets him apart,
Yeah.
right? He was one of the pioneers of the scientific method. He wanted proof, evidence, not just theories.
Exactly. He emphasized observation and experimentation.
And he made some remarkable discoveries about magnets, too. Like, did you know that if you cut a magnet in half, you don't end up with one North Pole and one South Pole?
What happens then?
You get two completely new magnets, each with its own North and South Pole.
Oh, wow. So it's not like splitting a battery in half.
Nope. It kind of blows your mind, right?
It does. You'd think you'd separate the North from the South, but it actually shows that magnetism is a property of the entire material.
Right. It's like the magnetic forces distributed throughout. Now, his curiosity didn't stop at just magnets, though. He also had some interesting ideas about the universe. For instance, he believed in diurnal rotation.
Diurnal rotation. I'm not familiar with that term.
It just means the Earth rotating on its axis, which causes day and night.
Yeah.
Seems obvious to us now, right? But back then, many believed the Earth was stationary.
The geocentric view of the universe.
Exactly. They thought everything revolved around us. But Gilbert was challenging that idea.
So he was suggesting that maybe we weren't the center of everything after all. That was pretty radical for his time.
It was. And he didn't stop there. He also questioned the idea that the stars we see are fixed in place. He argued that they're all different distances from us.
Really? So not just points of light on some giant sphere.
Right. You can imagine how mind-blowing that was for people back then.
Yeah.
But there's even more. Gilbert actually coined the term electricity.
Wait a minute. Electricity. He coined that term.
He did. The word we use every day for the energy that powers our world. And it all started with his experiments with amber. You know, amber, that fossilized tree resin.
Yeah, I know amber. It's often used in jewelry. It's beautiful, but what does it have to do with electricity?
Well, he observed that when you rub amber, or elektron in Greek, it attracts things like feathers or bits of paper. It's static electricity. And he called this force the electric force.
Wow, so it all started with amber. Who knew?
Right. But here's the interesting part. He was already trying to distinguish this electric force from things like air.
So he was recognizing that it was something unique, a distinct force.
Exactly. He even wrote about it. Listen to this. The electric effluvia differ much from air, and as air is the Earth's effluvium, so electric bodies have their own distinctive effluvia.
Electric effluvia? That sounds pretty mysterious.
It does. And of course, his theory of electric effluvia wasn't entirely accurate.
So what did he get wrong?
Well, he believed that these effluvia were some kind of emanation or fluid coming from electrified objects.
But we know now that it's about charges, right? positive and negative charges.
Right. But the amazing thing is that he was already recognizing that electricity and magnetism were different.
Oh, that's interesting because we know now that they're connected, right,
Okay.
through electromagnetism.
They are. But Gilbert was already on the path to understanding that, even back then. Now, not all of his ideas were spot on, though. For example, he believed that crystals were formed from compressed ice.
Compressed ice, so not quite right about that one.
Nope. We know that's not how crystals are formed. But hey, everyone makes mistakes, right?
Especially when you're trying to understand things that have never been explained before. It's all part of the scientific process.
Absolutely. And even if he got some things wrong, his dedication to observation and experimentation was remarkable. He even attempted to map the moon without even a telescope.
Wow, really? Mapping the moon without a telescope? That must have been a challenge.
It was. And he got some things wrong, like thinking the light patches were water. But the effort itself shows his dedication. He really wanted to push the limits of what was known, even with the limited tools he had.
It's inspiring to see that kind of curiosity and determination.
It is. And there's even more to his story. After De Magnete, he started working on another book, the Mundo Nostro Sublunare Philosophia Nova. It translates to New Philosophy About Our Sublunary World.
And this book, well, it really shook things up.
Oh, how so?
Well, it directly challenged some of the long-held beliefs of his time, especially about the nature of the universe and the Earth's place in it. I'm intrigued. Tell me more about this new philosophy.
Well, for centuries, the prevailing view was that the Earth was the center of the universe, right?
Right, the geocentric model.
Exactly. And Gilbert's work, especially De Mundo Nostro Sublunare Philosophia Nova, challenged that.
It's amazing how his ideas about the Earth's magnetism led him to question the whole structure of the cosmos.
It is. He was connecting the microcosm with the macrocosm, so to speak.
So how did this new philosophy challenge the geocentric view?
Well, Gilbert argued for a more dynamic view of the universe. He believed that the Earth was not just a static object sitting at the center of everything.
So was he suggesting that the Earth moved?
Yes. He proposed that the Earth rotated on its axis. This is what we now call diurnal rotation, which explains why we have day and night.
So even though he wasn't explicitly saying the Earth goes around the sun, he was definitely planting seeds of doubt about the geocentric model.
Absolutely. His ideas were paving the way for a heliocentric view of the universe where the sun is at the center. And of course, this would later be confirmed by astronomers like Galileo and Kepler.
Right. Gilbert was a pioneer in that sense, challenging the established worldview and opening up new possibilities.
And it wasn't just about the Earth's motion. He also had some fascinating ideas about the stars.
Oh yeah, what about the stars?
Well, he didn't believe that all the stars were fixed on some distant celestial sphere. He argued that they were at varying distances from us, scattered throughout space.
So he was basically saying that the universe was a lot more vast and complex than people previously thought.
Exactly. He was imagining a universe that was truly three-dimensional, with stars spread out in all directions.
That must have been a pretty radical idea for his time.
It was, and it shows how his thinking was truly ahead of its time. He was envisioning a universe that was far grander than the one described in the traditional texts. Now, De Mundo Nostro Sublunare Philosophia Nova wasn't published until after Gilbert's death.
So did his ideas have as much impact as De Magnete?
Well, it's hard to say for sure, but it definitely generated a lot of interest and discussion among scientists and philosophers. Some praised its originality and bold ideas, while others criticized its style and some of its more speculative claims.
It sounds like it was a pretty controversial work.
It was. But even the criticism is a testament to the power of his ideas. They were challenging the status quo, forcing people to rethink their understanding of the universe. And it wasn't just abstract theories. He backed up his ideas with observations and experiments.
So he was a true scientist, in the modern sense of the word. He believed in the power of evidence and empirical investigation.
Absolutely. And his work had a lasting impact. For example, the famous astronomer Johannes Kepler was heavily influenced by Gilbert's ideas about magnetism.
Kepler, the guy who figured out the laws of planetary motion.
The one and only. Kepler was trying to understand why the planets moved in elliptical orbits around the sun. And he's inspired by Gilbert's concept of magnetic forces acting over distances.
So Gilbert's work on magnetism helped to inspire one of the key breakthroughs in our understanding of the solar system.
It did, and it shows how influential his ideas were, even beyond the specific field of magnetism. But not everyone was a fan of Gilbert's work. The philosopher Francis Bacon, for example, was quite critical.
Oh, what didn't Bacon like about Gilbert's ideas?
Well, Bacon thought that Gilbert relied too heavily on magnetic forces to explain everything in the natural world. He felt that Gilbert should have considered other factors and not just focused on magnetism as the answer to every question.
It sounds like a classic debate between different scientific approaches.
It was. Bacon was advocating for a broader, more systematic approach to scientific inquiry. He believed in testing hypotheses and considering multiple explanations, not just jumping to conclusions based on one favored theory.
So it was a healthy scientific debate, really, different perspectives challenging each other to refine their ideas.
Exactly. And it's important to remember that these debates were happening at a time when the scientific method was still being developed and refined. It was a time of great intellectual ferment, and Gilbert was right at the heart of it. But despite the criticism, many other scientists and thinkers recognized the value of Gilbert's work. They praised his emphasis on observation and experimentation, his willingness to challenge traditional views, and his contributions to the emerging scientific method.
It's a reminder that even the most groundbreaking ideas often face resistance at first.
It's true, but Gilbert's legacy has endured. He's considered one of the founding fathers of modern science. His work on magnetism and electricity, his challenges to the geocentric model, his emphasis on observation and experimentation, all of these contributions helped to shape the scientific revolution that was transforming Europe.
It's amazing to think how his ideas, once considered radical, are now fundamental to our understanding of the world.
It is, and it's a testament to the power of curiosity, critical thinking, and the relentless pursuit of knowledge. Now, I want to circle back to Gilbert's work on electricity for a moment. We touched on it earlier, but I think it deserves a deeper dive, especially considering how essential electricity is to our modern lives.
You're right. It's easy to take electricity for granted, but back in Gilbert's time, it was a complete mystery. What were some of the key things he discovered about this force that we now rely on for so much?
Well, Gilbert's work on electricity was truly groundbreaking. You have to remember, this was a time when people thought magic or spirits caused many natural phenomena.
It's hard to imagine a world without electricity now. It powers everything.
I know, right? Back then, it was a complete mystery.
So how did Gilbert approach this mysterious force?
Through observation and experimentation, of course, he was determined to understand it in a rational, scientific way.
And it all started with his experiments with amber, right? That fossilized tree resin.
Exactly. Amber had been known for centuries for its strange ability to attract small objects when you rubbed it. Oh yeah, I remember learning about that in school. They called it the amber effect or something like that.
The Greeks called it elektron, actually, and that's where Gilbert got the term electric force from.
So that's where the word electricity comes from the Greek word for amber.
It is. And from those simple observations with amber, he started to unravel the mysteries of electricity.
It's amazing how something so seemingly basic could lead to such a huge leap in scientific understanding.
It really is. And Gilbert didn't just observe, he experimented. He meticulously documented his findings. He tried different materials. He figured out what worked, what didn't.
It sounds like he was really laying the groundwork for our modern understanding of electricity.
Absolutely. And he even invented a rudimentary electroscope.
Electroscope, what's that?
It's a simple device that can detect the presence of an electric charge. It's amazing that he was already building tools to study electricity.
Wow. He really was way ahead of his time. But we talked earlier about his theory of electric effluvia. Was that completely wrong?
Well, his theory wasn't entirely accurate. He thought these effluvias were some kind of fluid that emanated from electrified objects.
Like an invisible aura or something.
Kind of, yeah. But we know now that electricity is all about the movement of charges, positive and negative.
Ah, right. So he had the right idea that there was something special about these electrified objects, but he didn't have the full picture.
Exactly. But even though his theory wasn't completely right, it was still a major step forward. He was trying to explain this phenomenon in a rational way, based on observation and evidence.
So about asking the right questions, isn't it?
It is, and he was asking those questions. And he made some very astute observations. For example, he noticed that electric attraction and magnetic attraction were different.
Oh, that's right. He was already drawing a distinction between those forces, even though we now know they're connected through electromagnetism.
It's incredible, isn't it? He was able to make that distinction even without the full understanding of electromagnetism that we have today. It really shows his genius.
So Gilbert was a real pioneer, a visionary. He helped to lay the foundation for our modern understanding of electricity and magnetism. He challenged the prevailing views of the universe, he championed the scientific method, and he inspired generations of scientists. What a legacy.
Absolutely. His work is a testament to the power of curiosity, observation, and the human desire to understand the world around us.
I think that's a great note to end on. William Gilbert, scientist, innovator, and a true rebel of the scientific revolution. Thanks for joining us for this deep dive into his incredible life and work. I hope you learned something new and are inspired to keep asking questions and exploring the wonders of our universe.